Welcome to Science Store online classes.
Don't forget to like our video and subscribe our YouTube channel for all the updates.
Welcome to all of you once again to the physics classes. We were discussing about motion in a straight line. In that much of the topic we have discussed and we have completed, and now we were talking about the numerical sums, and based on that some of the sums already we have discussed, and today we are going to learn some of the sums on numerical problems on relative velocity. Now the thing is, so we know that in motion in a straight line only two directions are possible. One is positive, one is negative. Any one of the two, if you take positive, means another one will be a negative direction. Now we will go through the problem in such a way that two parallel rate tracks run north to south. Say for example it is north and south, two parallel rail tracks run north to south. Train A moves with the north with the speed of 54 km per hour. Train A moves north with the speed of 54 km per hour. What I said already, if any value is given in kilometer per hour, that we have to substitute to or calculate, convert into meter per second, isn't it? We have to convert into meter per second by multiplying 5 by 18. Okay. Next moves. Train B moves south with the speed of 90 km per hour. It moves to south with the speed of 90 km per hour. For A it is this, for B it is 90, means 90 into 5 by 18, like that, isn't it? Okay. So 18 ones are 18 threes are, here it is 15 meter per second, and here it is how much? 25 meter per second. Next, what we have to find out? What is the velocity of B with respect to A? What is the velocity of B with respect to A? So one thing you have to take it as positive, one thing we have to take it as negative. Say for example this direction you are going to take it as positive, and in this direction you are going to take it as negative. Means this will be in positive direction, this will be in negative direction. It is minus 25, right? Opposite way. First is velocity of B with respect to A. Velocity of B with respect to A means what you have to do? VB minus VA is equal to how much? VB is nothing but how much? Minus 25 minus 15, isn't it? Minus 15. Then we are going to get how much? That is nothing but 40 meter per second negative. Means with respect to A, if you are traveling in A with respect to you, what it seems for you, it is going to move with 40 meter per second. Okay, which will go with, because we are moving in opposite direction, the velocity is get added. So in the negative direction it seems that it is moving in the 40 meter per second in the negative direction, 40 meter per second in the negative direction. Okay, that is the first answer. So next we are going to talk about, the next question is velocity of ground with respect to B. Velocity of ground is moving? No, ground is not moving. Say for example a person is standing here. Velocity of ground with respect to B. Velocity of ground with respect to B. Let's see. B, that is velocity of ground with respect to me, means Vg minus Vb. Velocity of ground with respect to B means you are traveling in a train B and you are looking at the ground. What it seems, if you are traveling in a train B, if you look at the ground, means it seems that ground is moving in that direction, no, opposite direction. So like that must be So ground, velocity of the ground will be 0 minus this is minus 25, which is equal to 25 meter per second. Okay, 25 meter per second. That is nothing but one more thing. So next we have to find out, that is nothing but velocity of monkey running on the roof of a train A against its motion. See, train is moving from north to south, a monkey is there, no, here. Okay, it is running on the train, okay, running on the train, roof of the train against its motion, means in positive direction it is going, but still here it is given in bracket with the velocity of 18 km per hour with respect to train A, with the velocity of 18 km per hour with respect to train A. Okay, so what is that? Velocity of 18 km per hour, velocity of monkey with respect to train A is how much? 18 km per hour. 18 km per hour means how much? 5 by 18, which is equal to 5 meter per second. No, it is 5 meter per second. But what happens with respect to train A as observed by the man standing on the ground? See, train, it is moving in the opposite direction, no? So monkey is moving in the opposite direction. The net velocity we can say, or velocity of monkey with respect to A is negative direction as it seems. Now what we have to find out? Velocity of monkey running on the velocity of monkey we have to find out. This is nothing but velocity of monkey with respect to train A as it is. Okay, so now as it is observed by the observer, we can write down MA, which is equal to VM minus VA. Okay, VM we have to find out. So VM, which is equal to how much? VMA plus VA. So VMA is nothing but minus 5 meter per second and plus that is VA is nothing but 15 meter per second. So you are going to get 10 meter per second is the velocity. 10 meter per second is the velocity of monkey. Means monkey seems that it is moving with the velocity of A. Okay, for with respect to train A, no, if you are at the train A, what it seems for you? You are looking at monkey, means monkey actually moving in that, no, opposite. But if you are in the outside, means the velocity of the train is larger. Velocity of the train is larger in such a way that however fast means it can't move faster than that of the train, no. Little faster if you move also, it will take backwards only, no, monkey to that. If suppose if I am going to see that monkey is traveling in one direction in a one train and the train is moving in another direction, monkey has to travel very faster. Okay, then only we can say, we can make out that a monkey is traveling in the positive direction. Otherwise, however faster it go, if train speed is very much stronger, it will pulls back only, no. You might have seen some movies, you know, when fight scene is happening, you know the people are running on the train, all those things in the old movies. Okay, you might have seen such thing. That is a relative velocity. Okay, that is not actually there here, but this is the concept of relative velocity. Go through once again, these problems are very, very important. This is about one problem in the relative velocity. So this is one more problem. A jet airplane is traveling at the speed of 500 km per hour, ejects its products of combustion at a speed of 1500 kmph relative to the jet plane. Okay, so say for example jet plane is moving. Okay, now combustion products, okay, it will allows in this way. Maybe it is a gaseous product, so I'm going to write down G. This is a jet airplane, I am going to write down it as J. Okay, a jet airplane traveling at the speed of 500 km per hour means the velocity of the jet airplane is 500 km per hour. Okay, and ejects its products, okay, of combustion at the speed of 1500 kmph relative to the jet airplane, okay, relative to the combustion product relative to the jet airplane is 1500 kmph, means gaseous particles are moving in the opposite direction, no, one is in this way, one is in this way, okay. Then what is the speed of the latter with respect to an observer? What is the speed of the latter? Means gaseous particle with respect to an observer. How to write down? That is Vgj, which is equal to Vg minus Vj. V gaseous particle, it is nothing but Vgj minus plus Vj. Vgj is nothing but 1500 plus Vj is nothing but 500, which is equal to 1000 kmph, okay, that is nothing but minus 1000 kmph, or we can write down like this also, that is 1000 kilometer per hour inverse, okay. Means to the observer what it seems? To the observer it seems that this gaseous particle with respect to him, they are moving with the 1000 kilometer per hour in the opposite direction, 1000 kilometer per hour in the opposite direction. So this is one more problem we have discussed in the case of relativity. Dear students, we were discussing about motion in a straight line, and in that we were discussing about relative velocity motions, and some of the topics we have discussed. Again, one more problem we are going to discuss. Just go to the board, we will read that. Two trains A and B of length 400 meter each. So one train is there, okay, one more train is there whose length is 400 meters. Both are having 400 meters, okay. One is A, another one is B, okay, are moving on two parallel rail tracks. In the parallel rail tracks, one is in the one track, another one is one track, okay. So with the uniform speed 72 kmph. So 72 kmph means how you have to take 72 into 5 by 18. Kilometer per hour means what you have to do? Meter per second you have to do. 18 ones are 18 fours are, okay. So 20 meter per second, per 1 second 20 meters it will move, okay. So both are 20 meter per second, they are moving 20 meter per second, this is also moving 20 meter per second. Now what happens? The driver of B decides to overtake A and accelerates by 1 meter per second. Acceleration is 1 meter per second square. After 50 seconds, the guard of B just brushes past the driver of A. What was the original distance between them? What was the original distance between them? Normally in a train what happens is, it is assumed that the driver will be here and the guard will be at the last, okay. Now this was the first scenario, okay. The next scenario what happens? That B is going to overtake in such a way that after 50 seconds, this will be the case. How it will? A will be somewhere, the driver will be here, the guard of A will be here, he is going to just brush past, okay. Just the guard is going to see the driver of A. Okay, then what was the original distance? See, after 50 seconds this was a case, no? This guard is at this point, this guard is at this point. I will limit as point to P, I will limit as point to Q, no? So this person will move this distance, before that distance was, I will write down X or I will write down D, okay, and after this distance he will move, now he is here, no. So what is that distance? That distance is nothing but we are going to take it as V naught T plus half A T square. If suppose that A was at rest, we can calculate, no. if suppose by assuming that A was at rest, B is overtaking this, means x is nothing but d. We are going x total. What is the total distance it has traveled? This person 400 plus d plus 400. No, so 400 plus 400 plus d he has traveled. So 400 plus 400, that is 800 plus d. No, so 800 plus d, which is equal to V naught is how much? 20 into how much? 50 seconds plus half into A is how much? 1. T is how much? That is 50. 50 into 2500, isn't it? Okay. So what happens? This is nothing but 1000 plus half of the 2500, 1250. So you are going to get 2250 minus 800 you are going to get. This is nothing but D. So D is equal to how much? If you take 800 means, okay, if you 800 if you going to take means, so 1000, okay, 450 you are going to get, 1450 you are going to get. Okay, so now next what you are going to get? Next you have to see that, okay, okay, but what we have considered? We have considered that A was at rest. Do you think that was a distance? That will be not accurate actually. But meanwhile, that A is also moving with the constant speed, no? Okay, that we have to subtract. That is nothing but relative velocity. See, if it was rest means this was the distance, so it was overtaking in this way. So we can calculate after 50 seconds. After the only data is given after 50 seconds it is here. Now what happens? That A is also moving, B is going to overtake in this way. Some distance was it has moved. No, that we have to subtract actually. So what was that distance moved by A? That is nothing but x is equal to V naught t plus half a t square. But acceleration of A is 0. So V naught t is nothing but 20 into 50, which is equal to 1000. So that implies actual distance is nothing but this. I will write down xb. So xb minus xa, which is equal to 1450 minus 1000, which is equal to 450 meters. Okay, this is one. So other problems also you have to go through it. Okay.
Don't forget to like our video and subscribe our YouTube channel for all the updates.